The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome to the second webinar today from Smart Vision. And in this topic, we're going to be looking at data-driven segmentation. My name is Charles Quinn. I'm an analytics consultant, and I work for Smart Vision. I'm joined online today by my colleague, Rachel Clinton. And Rachel will be making sure everybody's logged in correctly and fielding questions as we're going along. If you haven't joined any of these sessions before, just a few housekeeping points we'd like to make. First is that we record these sessions. So if you want to listen to it again afterwards, you can do so. With regard to the slides I'm showing, we always email out a PDF copy to you after the session has ended. And if you think it's relevant for some of your colleagues who maybe are not able to attend today, and you want us to rerun it as a private session, just ask us, drop us an email afterwards, and we'll see if that's feasible. With regard to asking questions, all the lines are muted, so we can't hear you, but if you use the chat facility, we'll try and answer them as we're going along. And obviously, if we run out of time, we'll follow up with you offline afterwards. So if you don't know who Smart Vision are, we're a technology company specializing in predictive analytics, and we are a partner to IBM and to SAS. So we're an exclusive partner for Blue Sky Statistics as well, which is an R-based tool. And we provide a lot of services around the technology itself, including consulting and training. But we'll talk about that in more detail later. We're a bunch of veterans, really, of the analytics industry. And each of the team has about 15 to 25 years of experience working in advanced and predictive analytics. I myself have worked for SPSS, IBM, and SAS at some point over the past 25 years. So we're very familiar with topics like segmentation and with predictive analytics in general. So let's just start off talking about data and about segmentation. This is kind of an interesting story, and this is from a story you can Google this yourself. It's actually about Google itself, and it's about a guy who was a designer and who ran a regular blog. You can see that the blog here was on 20th of March 2009. And he said, basically, today is my last day at Google. I started working in-house at Google almost 3 years ago. And he was introduced to visual design as a discipline at Google. And basically, he was leaving. And he was leaving partly because he felt that, that a lot of the decisions that were being made weren't really about design or leveraging his knowledge of design, but rather leveraging the data. As it turned out, there was a follow-up article that occurred sometime afterwards in The Guardian, said why Google has 200 million reasons to put engineers over designers. And they talked about HIPPO. HIPPO is this idea of decisions made on the highest paid person's opinion, as opposed to decisions made by data. And they made the point that in the world of the HIPPO, you ask the chief designer or the marketing director to pick a color, for example, a shade for an advert or a font that you're using, and that's the solution. In the world of data, you run experiments to get the right answer. And in Google's case, they ran 1% experiments showing 1% of users different shades of blue color for the Google AdSense. These are the little adverts that appear alongside the Google search terms. And they were experimenting with different shades of the font. And basically they said, we saw which shades of blue people liked the most, demonstrated by how much they clicked on them. And as a result, we learned that a slightly purple shade of blue was more conducive to clicking than a slightly greener shade of blue, and that allowed them to drive the decision. But the implications of that, given the scale of their business, was that they made an extra $200 million in ad revenue simply by picking a shade of blue for their adverts and for their AdSense adverts. Rather than one other shade of blue. And this is a very extreme example, of course, because obviously Google's getting billions of queries per day. It's a very extreme example of how data is used to drive a decision, which in turn is used to drive extra revenue. But the principle is the same. The principle is that that we look at data to tell us, to help us make decisions, to help us make better decisions, to drive the objectives, whether they be tactical or strategic objectives of of the business. So predictive analytics falls very much within that realm. Predictive analytics is very much aligned to trying to make better decisions based upon deeper analysis of data, perhaps deeper than one might get from, say, a reporting tool or from a BI system or something like that. When you look up predictive analytics, if you look at Wikipedia or something, Wikipedia makes a fairly good stab at defining predictive analytics. It says that this is an approach which encompasses a variety of statistical techniques from predictive modeling, machine learning, and data mining to analyze current and historical facts to make predictions about future or otherwise unknown events. So the main point that it's making there is that predictive analytics is a discipline that is derived from many other disciplines. It's a smorgasbord. It's a salad of different approaches, including classical statistics and machine learning and data mining and that sort of stuff. IBM make the point that it's the analysis of structured and unstructured information with things like mining, predictive modeling, and a lot of scenario analysis. So by unstructured, of course, we're referring to non-numerical data. We're referring to text or video or audio-based data. Something which is probably driving most of the growth in the big data. People talk about big data and the exponential growth in data. Most of that data is unstructured in nature. People talk about the Internet of Things, data driven from applications as much as driven from people. And segmentation has a role within predictive analytics. Okay, so it has a particular role. We'll talk on that in a little bit more detail. But when we look at predictive analytics or advanced analytics or data science or machine learning, whatever you want to call it, in general, in commerce, there are three classic areas where it's deployed, which is to acquire more customers, understand who the best customers are, and find the best way to connect with them, find the best messaging, take the best action to maximize what you sell to them. And in growing customers, growing means cross-sell, upsell, if you're familiar with those terms. It also means growing the level of information or intimacy of the customer. So understanding the best mix of things that are needed by customers and channels, or taking the best action every time they interact with you. And then, of course, on the reverse of that is retaining customers, and that is understanding what drives retention, what drives people to defect, how much does satisfaction have a role to play, can you predict that before it happens, before somebody defects to another customer, before they cancel their subscription, cancel their contract, and can you from as a result of being able to predict this outcome, can you take some sort of action to prevent them from leaving? So for that reason, retention or churn analysis is a big area within predictive analytics. And again, something like segmentation will have a role to play within that. So why is retention and acquisition, particularly retention, important to organization? Well, acquiring customers is expensive. It's not unusual cost or expense as much as retaining them. Understanding who's most likely to convert, therefore, is very cost effective, given that you're spending a lot of money trying to acquire customers. So a good segmentation strategy will help with that. 80% of a customer's profits often come from 20% of its customers. So that's the 80-20 Pareto rule. So understanding who your best customers are and what drives their happiness and what leads them to remain customers is kind of important. This, of course, is true in the not-for-profit sector when we're talking about charities, for example. Increasing customer retention rates by small amounts, such as 5%, actually has big effects on the bottom line. And a famous study by Bain & Company at Harvard Business School showed that increased profits by 25 to 95%. So in other words, incremental bit gains is one business area that can lead to compelling, very compelling ROI. Just as the example being in Google, where coming up with a particular shade for a font led to a very, very small increase in the click-through rate for adverts, but that in turn drives quite compelling return on investment with regard to the scale of their business and the amount of extra revenue they were able to drive given that approach. So when we talk about data-driven segmentation, where does it fit within all of this? I mean, segmentation isn't really about prediction per se. Segmentation is about trying to classify or categorize individuals or events, customers or companies, but based upon data. That's the data bit of it. So data-driven segmentation really refers to an analytical approach comprised of different techniques, lots of different techniques, that generally group similar things together, usually customers, in order to make a more informed business decision. So it's this business of grouping similar customers, similar people, similar events, similar businesses together, which is, you know, at the heart of data-driven segmentation. So in other words, we're using data to uncover previously hidden, but hopefully useful patterns. So with data-driven segmentation, we're doing this. Why are we doing this? Well, we're doing this in order to understand, for example, we might have certain objectives, such as, you know, who are our most loyal customers. So we're segmenting them in terms of loyalty. Or maybe we've got a particular product or new product or offering that we wish to make to our customer base. Who should we be offering it to? Should we just offer it to everybody, or should we tailor it and in such a way that it actually reflects their behavior or the type of customer they are? How has our customer profile or customer segments changed over time? It could be something like, where do we open our next branch? I mean, one of the examples we can show is an example of actually clustering not people and not businesses, but actual stores together based upon their sales pattern. So if you wanted to know what sort of branch you're going to open up or how you're going to stock it, you know, you could use demographic information and figure out which cluster or segment that branch is most likely to belong to. What products should we be developing? Are there segments that are poorly served that we don't really address within our business, within our customer base or our donor base? What are our customers' aspirations? Do we do a segmentation based upon a survey or attitudinal data? These are typical sort of hypotheses or different questions that people are using to drive their segmentation strategy. And it's a good piece of advice is to have some sort of objective in mind, to have a reason for doing the segmentation, rather than simply jumping straight into the data and segmenting the data and hoping that, you know, that something useful will come out of it. It's better if you've got some sort of reason for doing it to begin with, whether it be to offer, you know, a more tailored messaging, or whether it be to have a deeper understanding of how a customer base has changed over time. There has to be usually some sort of reason, and it will keep you, it will stop you from running down a number of different alleyways and wasting time trying to uncover something in a massive inverted commas, something interesting. That type of approach doesn't seem to be quite as effective. So when we think about data-driven segmentation, you know, we're thinking about segments, we're thinking about groupings. You know, we have to think about, well, how are we going to find these? How are we going to identify these groups? And, you know, hopefully we're going to yield something useful as a result of that. We're going to, you know, we're going to segment, we're going to uncover clusters or segments. But what do we mean by useful? Useful in what terms? You know, what constitutes a group? Can we actually say, can we effectively describe the sorts of people that fall within that cluster? Or are there so many different dimensions to it? It's actually very difficult to do. And what data should we use? I mean, should we just use demographic information? Should we use attitudinal data? Should we use transactional data? These are all, you know, grist to the middle type questions that we have to have when we're embarking on a segmentation exercise, if you like. So when you think about segmentation that already exists out there, I mean, you can actually go and buy from other companies ready-made segmentation schemas. So very famous ones are Experian, Mosaic, and Acorn, CI segmentation. There are also things like Prism from Nielsen, and then there are specialist ones for particular industries. There's Platinum Blue for music, and there's Berry Consulting used Fruits, and GeoSmart. There's this sort of geodemographic one from RDA Research, and then Call Credit Marketing Solutions, so use Cameo. You can go and buy, you know, a segmentation from another company, and that segmentation then is usually matched at something like a postcode or an address level to say, these are typically the sorts of people that live within there. This is the sort of segment that they belong to. So segments, in other words, a good segmentation strategy is valuable. It's so valuable that companies can actually go off and sell them to other companies. So examples of mosaic segments by Experian, I mean, they have these terms and much deeper descriptions as to who falls within these segments. We get things like clever capitalists, peripheral poverty, struggling families, affluent greys, stylish singles, that type of stuff. And these are descriptions of segments, but they're trying to come up with a nice, snappy title. Sometimes that's one of the hardest things to come up with, and you really need somebody who's fairly creative to help you come up with a label for your segments. And you can look up a postcode, for example. That postcode will go away and tell you, what sort of that postcode will be matched to a geodemographic segmentation strategy like Cameo or something like that, and it will tell you typically what the average age of people that live within that area are, what the level of credit score risk is, what their educational level is, etc. And this is a generalization, of course, because when you're dealing with a postcode, you're dealing with multiple households, sometimes 15 consecutive households, and there'll be a lot of different people in it. So it is very much a generalization, but very often for a lot of businesses, that's the best they can do. But segmentation is out there, segmentation is valuable, segmentations can be sold. There are other sorts of segmentation out there. So people talk about class, of course, social class. There's a fairly interesting and amusing book by a journalist called Harry Wallop called Consumed. And he comes up with his own segmentation strategy and applies it to the UK. It must be about 5 or 6 years old now, this book, but it's an interesting reading. It tells you a lot about the sorts of segmentation strategies that companies like Experian might come up with, and how they describe people in terms of social class and in terms of their shopping behavior. And this, of course, is the sort of approach is very, very interesting for retailers to try and figure out how they present their brand, what sorts of people will shop with them, and what sorts of markets they're going after. Sometimes segmentation is actually used as a form of messaging. This is from a long time ago. I can remember seeing adverts by Orange where they're offering different packages, different tariff packages to their customers. And a tariff is usually a rate plan. It's a plan. It's a different set of, it's a bunch of different services that can be offered. And of course, different people have different needs. So sometimes it's very confusing for people to remember what sort of tariff they're on, and what sort of plan they've got. They're often not very memorable. So they've literally come up with their own segmentation of their customer behavior, and then they've used that to drive marketing. So they started using animal plans, panther plan, dolphin plan, stay social, stronger emphasis on unlimited text, email, mobile, internet, canary, unlimited text, more minutes, that type of stuff. And they literally offer it. And it was seen as a very successful campaign. And one of the things that's interesting about it is they've clearly done a segmentation, and they're using that segmentation almost as a calling card to interact with their customers, saying, which segment do you think that you belong to? Okay, sometimes you have predetermined segment dimensions. Sometimes people have decided, well, actually, we already have a segmentation strategy. And we segment our customers in terms of 3 dimensions. We segment them in terms of how recently they've interacted or shopped with us, how frequently over their lifetime as a customer they've shopped with us, and how much money they've spent with us in total. So sometimes called RFV, recency, frequency, value, or something more often called RFM, recency, frequency, monetary analysis, is a fairly straightforward, very simple form of analysis. One of the things that makes it attractive to marketeers is the fact that it's something that you can do as long as you have aggregated the data. You can do this through a spreadsheet package. And secondly, people can think in 3 dimensions. It's easy for them to think in 3 dimensions. They can think of it as like a 3-dimensional pyramid, where the people, the slice right at the top of the pyramid is clearly the best customers, since they're the most recent, they're the most frequent, and they spend the most amount of money. And you can actually do this in various tools, statistical tools like SPSS Statistics, and as we'll see, IBM SPSS Modeler. These are kind of predetermined segment dimensions. People have already decided, these are the ways in which we are going to segment our customer base. Other types of segmentation include things like Net Promoter Score, where people are asked, and you'll see this, of course, you've probably seen this many times. Many of your organizations online today will be using Net Promoter Score to understand loyalty, where you ask people, how likely would you be to recommend us to a friend or a member of your family, our services, or our business, or our products, for example. And hotels do this, banks do this, power companies do this, look, insurance companies, loads of them do it, and it's a sort of standard way to segment the customers. In fact, they look at a scale running from 0 to 10. They ask people to score out of 0 to 10 how likely they would be to recommend them to a friend or family. And then the company then groups them together into anybody that scores 6 or lower is seen as a detractor, i.e. they're not very strongly likely to recommend you. People in this zone of 7 to 8 are seen as passives, and people in the zone of 9 or 10 are seen as promoters. Companies are then calculate based upon the survey what their net promoter score is, i.e. what the number of promoters they have, which is percentage of promoters minus the percentage of detractors that they have. And the idea is that this is a very strong correlator with profitability and growth of the company. So it's something that's very interesting to them. And people are measured on this, executives are measured on it. We have an analytics, Smart Vision, we have an analytics application around predicting Net Promoter Score, around understanding what drives Net Promoter Score, using, for example, free text that people have put, have answered in surveys, or have written online reviews about companies or hotels or businesses or restaurants. You can actually, using that text, predict their promoter score and figure out what are the top 10 things that drive it, for example. Okay, but we're thinking about how your customers or how your donors or how your clients are actually characterized. It's very common for organizations to have predetermined segments, to say that we already have this concept of a segment within our business. And, we talk about our customers in terms of the various products that they have, and we have gold segment, bronze segment, or, we have our own labels. But very often that's driven by their own insight, driven by their own business knowledge. It's sometimes questionable whether or not that's the best way to characterize your customers. It may have a certain utility up to a certain point, but very often they're not actually looking into the data itself and saying, well, that's what you say, that's how you describe your customer base. But what does your data say? Does your data agree with you? About, when we look at their transactional history and we look at their behavior, can we actually use the data to derive an alternative segmentation of your customer base? And when we think about the data that we've got at our disposal, we may have some descriptive data. So we may have geographic data that we've already got. We may have data about their gender, about their age, about where they live. We may even know whether or not they're married or how many children they have. This sort of descriptive data simply describes who they are. And then we'll have, of course, potentially transactional history, so we know how much money was spent with us in the past, how frequently they interact with us and spend money, and what's the minimum, maximum, what methods do they use, whether it be credit card or debit card or whatever. And these are the two classic dimensions that people use. Very often, the more sophisticated applications will reach into other sources of data. So they'll look at interaction data, they'll look at how often that person comes onto the website or searches on the website, or how often they've called the company through their call center, or sent an email, or complained, or something like that. So the interaction is, it's quite a powerful way to see your customers, because it tells you a lot about their behavior as a customer of your organization. And then on the far end of it, you have things like social media data, which may be possible to harvest. But you also have attitudinal data, you have surveys, that sort of stuff. It may well be, of course, that for the vast majority of customers or clients or donors, you don't have information in all of these 4 sources, but that's not necessarily a problem. You can actually work with a subset of data, or utilize the data that's that's available for that particular person at a particular point in time. Some of this data may be unstructured in nature, so it may be text-based, in which case you may be required to do some text mining. That's not necessarily as complicated or as scary as it appears. A lot of text mining engines these days will automatically extract terms and type them and class them into negative or positive terms. So you can start to see what people are talking about and how they're talking about it, and you can often do that out of the box. So some of the tools that we sell allow you to do that. The point is not to discard it, not to discount it, and simply to think a little bit deeper about all the different islands of data across your organization that you could use in order to develop your own segmentation strategy. And by deriving your own segmentation strategy, of course, what you're hoping to do, generally speaking, is to drive more appropriate interactions and not treat people as all one homogeneous group. So techniques like cluster analysis, which we'll see shortly, can uncover subtle differences and previously hidden groups. And of course, as I said earlier, one of the tricks then is to try and think about how you're going to label those customer groups, whether it be anything from pioneers or loyal latents or business bedrock or do not disturb or whatever phrases you want to use or you feel are best to describe them. Okay, what techniques like cluster analysis are doing is that they're trying to find natural groupings in the data. They're trying to find rows that are similar to each other, rows of customer data that are similar to each other. And the rows, as I say, might be demographic information, maybe transactional information, maybe a combination of both. And the advantages are it can find very subtly different segments that might otherwise have been missed. Of course, it's slightly more objective because letting the data tell its own story. It can utilize multiple dimensions, so it doesn't just have to be recency, frequency, monetary. It can be 20 different factors could be fed into it, and it will take into consideration all of those 20 factors in order to group or create clusters of segments. And it can be very powerful, of course, when it's combined with reporting platforms such as management information platforms and BI, because the clusters that are created, the segments that are created, can then be fed back out into the reporting tool, and you can then start to see, how those behaviors, how those different groups of customers behave, and how they've changed over time. There are some disadvantages, however. The first thing is that it's not always obvious how many segments there should be. You can do a cluster analysis, and it may recommend 7 segments or 7 clusters, and run another cluster analysis, and it says 9, and another one that says 4. So you have to make a guess, or you have to make some sort of educated judgment as to how many segments it should be. In other words, it's not necessarily as objective as it could be. And you need to be careful when you're interpreting it. So you really need to look at what is the difference between, say, cluster 4 and cluster 3, for example. Often they can't automatically select the most useful fields that you put in, the most useful variables. So, for example, if you're putting in something like age, and age really doesn't make a difference. It doesn't necessarily know that. So you often have to think about really carefully about which fields you're going to put in. And it's good if you have some sort of business knowledge up front. So in other words, don't treat it like a cement mixer and just chuck in a whole bunch of data and hope that it's all going to be useful at the end of it, and every field you're putting in is relevant. Correlated variables may be measuring the same thing. So in other words, if you're measuring spending in 9 different categories, one of the things you'll often get is that people who spend high in one category spend high in all of the other 8 categories as well, because they just spend a lot of money. So if the fields are really ultimately measuring the same thing, then you're effectively double counting them or triple counting them when you put them into a cluster analysis. You want to put in fields which are quite measuring very different things from one another. It's not always a major problem, but it's just something to bear in mind. And the results aren't always obviously usable. I mean, for example, you can come up with a very good segmentation strategy, and you can say, okay, well, I've done my cluster analysis here, and I've got 5 clusters. Now what do I do? Well, it doesn't necessarily tell you what to do. That's why it's important to have some sort of objective or plan up front as to why you're doing the cluster analysis to begin with. Because it's not necessarily going to tell you, well, you should market this way to this sort of group, or you should interact with this other group in this other way. You really need to have some sort of set of objectives beforehand. An example of segmentation for detection is an example I've worked in the past, where we were working for on behalf of a company, and the company was trying to find small businesses within credit card data. So some of those businesses were just sort of tradesmen, so plumbers, builders, that sort of stuff, and some of them were just private consumers, people doing DIY. And they're looking within the electronic point of sale and credit card data to try and find out, what sorts of clusters they're forming. Can they find a cluster which is probably made up of lots of small businesses, not individuals? So after a while, the cluster analysis shows that you've got roughly these two dimensions. You've got people who are coming in very regularly into the stores. They're spending a lot of money. They're usually using the same sorts of materials, so they're always buying paint, and they're always buying wood, or they're always buying plumbing supplies, and they're going to different stores. Now, if that's the case, the chances are that they're probably a small business as opposed to an individual private consumer, because they're going to different stores and they're buying the same materials over and over again. Whereas people who are spending intermittently, buying a lot of household goods, tools, and it's fairly sporadic, and they're much more likely to be consumers as opposed to small businesses. And by identifying the different clusters, we then match delivery addresses to those clusters. You're able to find certain clusters where you have a lot of delivery addresses with things like and Son and Limited associated with them. So that indicates that they're much more likely to be businesses rather than consumers. Exactly the same approach is used, interesting enough, in anomaly detection, where they're trying to identify unusual behavior, potentially fraudulent behavior, because often you don't have an actual flag or an indicator in the data that says this is a fraudulent transaction. What you have is unusual behavior. So cluster analysis or segmentation techniques like cluster analysis are quite a good way to identify these anomalous groups. Okay, let's skip out and we'll do a quick demonstration. So we're going to go out into IBM SPSS Modeler. We'll look at a couple of little examples here. So one of the first ones, I did mention RFM earlier on, recency, frequency, monetary. I just wanted to point out that in recency, frequency, and monetary data, you have you can create information which will, let's see if I can find this. I think that might be the wrong stream. Let's see if I can find another stream. Here. Oh, there we go. This is the correct stream. We've got some RFM transactions here. Let's just look at this data. I'll just show you what this data looks like. Let's change this so it's the D drive and the C drive. Okay. Let's look at the full data set so we see what we're working with. Okay, so run this. Here we've got a full data set. So we've got 4,906 records here. Okay, so we've got a particular product that somebody's purchased, particular product number, we've got the date, and we've got the amount. So this is the raw transactional data. This person may reoccur several times within the data. The key is that we know when they purchased, we know how much they purchased, and we know over a period of time how many times that ID appeared. And that's basically our three dimensions. The product line's not terribly important. The product number is not terribly important. It's just the amount and the date and who they are. If we use the RFM tool within here, you can see it says, okay, tell me what the ID field is. Tell me the credit card number or the customer number. Tell me what the date field is, and tell me what the value field is, which is how much they spent. When we hit preview at that point, it goes off and aggregates the data and says, okay, this ID here, number 955 times. Well, the most recent time that they shopped with this was 167 days ago. The amount of times they've shopped with this is 6 times, and the total amount of money that they've spent is $448 or pounds. So it creates those 3 dimensions, and then we can use the RFM analysis here, where it says, okay, tell us what your recency, frequency, and monetary is, because it creates those fields for you. And it bins the data. That means it bands the data into fifths, basically into 20%. That's the convention. And what we get out the back of that is we get this this score. So we get the recency score, frequency score, the monetary score, and we can see here, for example, here's quite a large number here. This is the monetary score here. You can see this monetary score is coming in at 5. 5, it means that they're in the highest group. So the higher the number, the more recent. So this person here is very frequent, highest group frequency, highest group for monetary, and about middling for recency. So they haven't shopped for a while. This person here, you can see the recency is it's 531 days ago. So they're not very recent at all, as opposed to this one down here where they've shopped within the last 5 days. So we can create these dimensions here, and we can create this overall score where if they get 555, well, we know that they're the people who have they've got the highest RFM score. So we could sort that data. Normally, the convention, the approach that is taken is that the people you really want to retain, the people you really want to look after, are the people who fall into the highest recency, the highest frequency, and the highest monetary value, of course. So very often they'll sort it and they'll say, okay, let's sort it by the monetary, the RFM score here, and we'll say sort it in descending order. And then you would top slice maybe the top 20% of that and say, okay, these are the people we really need to look after. They're the people spending the most, they're the most frequent, the most recent. You see they're 555 for all the way. So scroll down through this. You can see that so it stops around about record number 35. It's only 35 customers there. Not terribly surprising that out of 955 that scored top marks in all 5 of these areas. So it doesn't have to be fifths. It could be tenths. You could do it in deciles. But you can see it's a very simple approach, and it's quite effective actually. It's quite a decent way to do RFM analysis. Perhaps one that's a little bit more involved in that is to look at a cluster analysis. So we've got cluster analysis here. We've got some charity data, and if I just show you this data, this is some data I derived for a charity organization, and the charity itself really didn't have a lot of information about their customers or about their donors at all. So much of the data was created by myself. So for example, I knew the amount that donated because I could see the individual donor IDs. I could see the total amount of donated. You can see that it goes from anything from £12 up to £16,000. Some of these are legacy donors, and the average amount that they spend, the average amount that they donate, the average goes from 6 to 3,406. And then I started to count things like the number of times they changed their method of donation. So this is kind of like an interaction measure. So I would run a little routine to calculate how many times they change the method. And the point is that we're trying to discriminate between customers or donors who are supporters, who are basically inert and who have a direct debit set up and who are pretty much donating the same amount, or maybe they send off a check every single month for the same amount every single time. They're very different, of course, from other donors who change the method. That sometimes it's credit card, sometimes it's debit card, sometimes it's direct debit, sometimes it's check or cash or whatever, and that says a lot about them. The same when they change the amount. They're much more invested with the charity if they're changing the amount over time. They're still remaining. So, and the number of transactions itself. Then we've got gender, and we've got their tenure in months. When their first transaction appeared, when their last transaction. We've got some rough information about their age. You can see somebody here is put down as 6 years old. Is that a mistake in the data? It might be. If we just double click on it, you can see there aren't very many people. Most of it's down about, and there's not very many under 20 at all. The vast majority are around about this sort of middling group here. And then we've got a very important field here, which is their main channel. The main channel is direct mail, or through periodicals or affinity channels, so other websites, other charities that point them in that direction. Directly through the web itself, and then events and miscellaneous would be, charity events, sponsored walks, sponsored runs, half marathons, that type of stuff. So very different sorts of channels, and then we have a flag, i.e. whether or not they are direct debit customers, or sorry, direct debit supporters. Very often, your ideal supporter will be somebody who's don't press the help button there. People who are direct debitors and who are donating a lot each month, because it's fairly frictionless for the organization. We've also got, because this data goes back sometime, we've also got information here on the last year of donation. So we can see that this data was originally collected in 2013. And about half the data was made up of people where their last donation was in 2013. About a third of the data, the last donation was the previous year, and about 17% here. The last donation was in 2011, so they haven't donated in the remaining 2 years. So that's kind of interesting, and it might help us understand the differences between these different segments, these different groups. Okay, when it comes to choosing a method, a cluster analysis method, there's lots of different methods. If we go down here to segmentation, you can see, look, these are all different sorts of cluster methods. And it may be a bit bewildering to people as to which method to use. So it turns out we've got what's called an auto cluster, which will basically automatically run the cluster analysis, trying out different methods, and then choose the best based upon a particular criteria, which we'll come to in a moment there. So it was building up to 8 different cluster models using different methods. And it's found a solution. The solution appears in the form of a sort of gold nugget, because it's sort of related to data mining application. If we look at inside this nugget, we can see the top 3 solutions. So one of the solutions here has 6 clusters. One of the solutions has 5 clusters. And one of the solutions has 10 clusters, okay? And the one which has been chosen as the best is number 6 here. And the reason that is because it's got this thing called a silhouette measure, which is 0.394. This one here is only marginally less at 0.391. And the silhouette measure is basically a measure where it attempts to say, how different are the clusters from one another? So it's trying to create quite homogeneous groups that are different from one another. It's a very, very rough indicator, so I don't pay too much attention to it, but it's a good start. And in this case, because there's such a small difference between 391 and 394, and because I'm just using it for illustrative purposes, I usually start off with the smaller number of clusters, because it's often easier to try and tell the difference between them. So if I double click on that little chart there, you can see that here are the cluster groups: cluster 1, cluster 2, cluster 3, cluster 4, and the smallest one's cluster 5. But of course, we're stuck with this problem. Well, who's in these clusters? It doesn't tell us. But if we look inside the model itself, we double click on the model, what happens is it opens up this little viewer, and it tells us the cluster quality based on k-means is reasonable. It simply gives us a pie chart now, telling us what the relative sizes are of the clusters, and it color codes them. The lightest one here being, the pale blue one here being cluster group 1, and the yellow being cluster group 5. It tells us the size of the smallest cluster, the size of the largest cluster. And then we've got what's called model summary. If I click on clusters here, it starts to go down into the individual clusters themselves and what makes them up. And it sorts them in order from 3 down to 5. Well, I'm going to sort them in numeric order by using this little button here. It sorts them back in numeric order. And it's showing me what is the most important field for that result, that cluster solution, that segmentation solution has come up with. So you can see the most important field it's come up with is whether or not they have direct debit, and the least important is the average gift value, interestingly enough, because it's harder to tell, to come up with homogeneous groups based upon that. But if we look at, for example, cluster group 1 here, if I click on that, it shows me, that 81% of them are no's, and in the background it's showing me how this compares to the overall distribution. So cluster group 1, most of them aren't using direct debit, which isn't too different from the average. Cluster group 2, 100% of them are not using direct debit. So nobody in cluster group 2 is using direct debit. Cluster group 3, also 100% not using direct debit. Cluster group 4, 100% are using direct debit. And cluster group 5, they're all using direct debit, even though it's a relatively small number. In the same sense, the next one down is gender, which is seen as important. So cluster group 1 are males who do not use direct debit. Cluster group 2 are males who do not use direct debit. Cluster group 3 are females who don't use direct debit. And cluster group 4 is probably close to average. I think there's probably more females in there than males who do use direct debit, and cluster group 5 is actually got a majority of males, 58% using direct debit. Then we come down to main channel. So now we're looking at the main channels. If we click on that, we can see that everybody in cluster group 1 is using periodicals affinity. Cluster group 2, mostly direct mail, a little bit of web. Cluster group 3, similar thing here, direct mail, but also periodicals and affinity. Non-direct debit, all female. Cluster group 4 here, very strong showing for the web group here, 48% from web, that's the modal group. And the last one here, for cluster group 5, they're all donating via events and miscellaneous. So they're actually taking part in events. Then we have information about the number of transactions. So here it's showing me the overall transaction. But if I normalize this, so you can see this against, you can see that this is what you can see everything updates here to normalize. You can see where the majority of the transaction distribution is for that group, as opposed to cluster group 2. We've got a bit of a bump here, cluster group 3. And they've got a lot of transactions, not terribly different. Cluster group 4, cluster group 4 now, we're starting to see transactions shifting towards these people here have made a lot of transactions. And cluster group 5, well, they've been very, very loyal. They've been making a lot of transactions. And the same with changes in methods of payment. So we start to build up a picture here of the differences between the cluster group here. Cluster group 5 changed the method of payment a lot. If we want to compare them all, we can click on the header, and it starts to build up a picture of how they compare. So we can say that cluster group 2, cluster group 1 and 2 and 3 mostly made up of people not using direct debit. 4 and 5 mostly made up of people using direct debit. Here's the breakdown in terms of male and female for different colors. Here's the main channel. Here you can see number of transactions. This is showing me the median value of the 25th percentiles either side of that. Compared to everybody else, cluster group 5 dwarf everybody else in terms of number of transactions. Cluster group 5 is also very high in terms of the number of payment methods. Down here we've got tenure in months where it starts to, it's a little bit different. So yes, cluster group 5 have the highest tenure. Cluster group 4 also have a tenure of 24 months. Cluster group 3 are bang on average 22. Cluster group 2 are the lowest, 19 on average, and cluster group 1 also at 19. And then you see differences in age. So doing this, we can build up a picture of what the cluster groups, who belongs to these different cluster groups. So at this stage, we would normally be, starting to make a note and trying to assess whether or not this is a good cluster group solution. We'd be looking at other solutions and seeing if they help us to discriminate between different groups. Remember, this is all driven by the data. If we look inside this specific cluster solution, this is what's called the k-means. It just means k averages or more than 2 averages. When we look at that, what that actually creates for us, is it creates a new field indicating which cluster that person belongs to, and also a little measurement here of how close that person is to their cluster center. So if you get a very large number here, like this number here is quite large, this person's relatively far away from the cluster group center, so they're kind of on the margins, whereas somebody down here at 0.0193, they're quite close to the center. So it gives us an idea of how typical that case is. Okay. And if we wanted to describe these segments, I can switch to another example here where I've finally come up with my cluster solution here. Here it is, k-means. This is the one I'm using. I'm quite happy with it. And I use a little node here to describe them, and I come up with descriptions to say, okay, who belongs into these different cluster groups. I've got 5 cluster group solution here. So I'm calling cluster group 1 male cash readers. I'm calling cluster group 2 core direct mailers. Cluster group 3 bedrock female responders. Cluster group 4 high value direct debitors. And cluster group 5 super loyal direct debitors. Obviously, you could come up with your own descriptions. You may disagree with those, but as a starter, that's probably a reasonable one to begin with. And if I look at this broken down by last year of donation, what we see is it's quite interesting because we see this how these cluster segments have shifted over time. So I just go to type the graph here. You can see that in 2011, this was the profile. You can see the largest group was the bedrock female responders. By 2012, this group has shrunk. This group here has got slightly larger, which is the male cash readers. Also slightly larger is the high-value direct debitors. By 2013, we're starting to see the emergence of the super loyal direct debitors that are starting to fall into that threshold. And the bedrock female responders is also shrinking. So this approach of having a cluster solution means that we can take this object and we can attach it to historical data, and we can monitor and say, well, how have these cluster groups, how have these segments changed over time? And of course, this is all driven by the data itself. So that's an example of doing a cluster analysis to derive a segmentation strategy and to name those segments, and then to look at how they've changed over time. We might, for example, use these segments to interact with these donors, these supporters, in a way that is meaningful and reflects the type of donor they are. And the last example here, just very quickly, I'm just going to go very quickly, is just to show you that it doesn't always have to be customer people. This data here is actually data from where each row within the data is a different store. And we've looked at the percentage of sales in that store that have been devoted to things like hardware or toys, bathroom, that type of stuff. And we've clustered the stores together. Now, what's interesting is when we cluster the stores together, we've actually come up with a 25 cluster group here. This is what the clusters look like when we cluster them together. When we overlay the region by that, even though region wasn't used in the cluster analysis, what's fascinating is that the stores do cluster together regionally. So that means that their sales pattern almost predicts what sort of region they're in. So for example, here we have, these are all London stores up here. These are London stores, these are London stores. You don't know what the difference is between these ones. These ones here are on a retail park, these ones aren't. Here we get a lot of these blue circles appearing. These are people in Anglia television region and also the Yorkshire region. Down here we see a lot of Yorkshire and Granada TV regions. Down here we're seeing a lot of Northern Ireland, Ulster TV and Grampian. And down here we're seeing a lot of Tyne Tees and Scottish TV, STV, and also Granada. So it's kind of interesting. There's one group in here which is very, very homogenous. I think it might be this one or this one up here. But when we actually delve down into it, we find out that many of these stores were in fact coastal stores. So that's why they were in different regions. And it was almost as if the coast itself was a region in itself, because they tend to sell, very similar products. And the value to that retailer means that, when it comes to stocking those stores, they can look at the cluster profile of that store and say, well, this store on average sells, 5% less toys, 20% more gardening tools, 17% less jewelry, that type of thing. And they would stock the store according to its cluster group that it belonged to. So it meant that they don't have to have a different individual. They don't necessarily have to have a one-size-fits-all stocking plan, but at the same time, they don't have to have an individual tailored stock plan for every individual store. We can come up with something that's somewhere in between, and it makes it much easier to manage. Okay, returning to the slides here. So finishing up there, good advice for segmentation initiatives. First of all, ask yourself, why are you running a segmentation in the first place? What is it you're trying to get out of it? Is it just insight, or is it you're going to make a decision? Is there something you're going to do off the back of it? Because that's very important. The second thing is to reach further for the data. Don't just use demographics and transactional information. If you can harness attitudinal data, that's good. If you can harness interaction data, for example, how they interact with the customer, how often they visit the store, how often they come onto a website, that's very powerful. Only use data that counts. Don't put in junk data. You're not going to be putting in things like sign of the zodiac or something like that, or their address or something like that. You need to think about, try to be a bit more disciplined about it. Think about how many segments there probably are in terms of your own intuition, your knowledge of the business, your organizational data, how they talk about customer segments, and how many you can handle. For example, if you come up with 19 segments, can you do anything about that? Can you create 19 different creatives for that? Probably not. So, very often a good start is to ask for 5 or 6. The segments, of course, should be chosen on the basis that they're distinct, that they're reachable, i.e. that you can actually identify them. You can say that these are the people in there, and that they're valuable. That you say, well, this is actually a valuable segment, or this is not so valuable. Think about what you're going to do with the results. think about how you will know if it's worked. So if you are going to make decisions on the back of it, you're going to offer different things, different segments. Perhaps you need a control group where you have a sort of business as usual approach, and then you measure whether or not a segmentation strategy was helpful. And think about what you're going to do next. Beyond segmentation, what else do you do? Do you get into the more predictive world of trying to predict whether or not people are going to remain customers, or whether or not what their next move is going to be, or what's the next best thing to offer them? Because that's all part of the same continuum. Okay, with regard to working with us, well, you can buy your analytical software directly from us, often with discounts. And we can assist with things like an initial pilot project, helping implement, support the analytical tools. And really, our modus operandi is to try and make organizations self-sufficient. So we're not in there as a sort of consulting house that's doing everything for an organization. Rather, we work with you in your first segmentation project, for example, and then we teach you how to use the software. That way we can leverage your own business knowledge, your own domain expertise. And with regard to consulting services, of course, training is part of what we do. So we run training courses in this sort of thing all the time. We do classroom-based training, or side-by-side based training. We do a lot of web-based support, that type of thing. And we also offer the ability to identify and recruit people with analytical skills in your organization, because we're used to doing that ourselves as managers within technical organizations, where we've been recruiting our own statisticians and our own data miners and our own data scientists and our own analysts. Generally speaking, we'll give no strings attached advice and support. So we are technical support providing partner to SAS and IBM. So we do provide technical support directly to our own customers. I do hope that you find that useful. There are other web sessions that we've got coming up. We do this on a regular basis. You'll find out more information about that if you go onto our website and see what the calendar is of upcoming events, and you register in exactly the same way you did today. I know it's not quite the weekend yet, but in advance of that, I hope you do have a good weekend and an enjoyable end to the rest of your week. Thanks very much, and we look forward to you logging in again.